Hello, this is a test, I guess, but it's the day before the exam, the paper three. So I thought I'd just do an Ask Me Anything for paper three. If anyone's not sure, just shout and I'll try and guide you through as best as I can. So if you've got any last minute questions regarding the exam, um, just shout. Hopefully by now, I think everyone will have done the. I think both practicals have been written, and yeah, if I can help in any way, just shout. I see one person. This is just a bit of an experiment to see if this even really works. The one person is gone, so I'm just going to chat to myself. This is me chatting to myself, waiting for someone to ask me a question because they're doing last minute revision or something. I don't know. Anyway, so if you want to, if you're not sure about something, so one person was asking about diffraction grating. So if there's something you're not sure about, just ask in the chat. I'll try and help you as best as I can. Just for maybe, well, see how we get on. If this thing goes well, we shall see. If no one's there, no one's interested, then I will call it a day. So if you've got any questions regarding the AS level exam, then just give me a shout and I'll try and guide you through any problems that you might have. So ask me anything. Any problems for the head? It's probably just all my students just watching me, just like, oh, what's he doing? Hello, 5 people. Any questions, 5 people? Now's your chance. Hi, Rebecca. I haven't done AS level physics in 4 years. Well, you obviously subscribe to my channel, so don't now unsubscribe because otherwise, this is what the problem is. Everyone's going to forget that they subscribe to my channel, and now they can be like, oh, unsubscribe. This could be the worst thing I've ever done because I'm suddenly going to get like minus 200 subscribers or something. But thanks anyway. Thanks anyway, Rebecca, for popping in. It's appreciated. I don't know how it works. Did this pop up on your phone saying, "Oh, Mr. Guzzle's doing a live stream" or something? Can you hear my audio, by the way? EMF of a source definition. So, what is EMF? It's okay. So, EMF. Firstly, the idea of EMF is that you have one kind of energy, and it's being changed into electrical energy per unit charge. So, I would say for EMF, when you have one kind of energy changing to electrical energy per unit charge. But there's something in the AS level paper that they like. What is it? When one coulomb goes around a circuit and it gives off one. Is it 1 joule of energy? So there is a definition that Cambridge seems to like. Can you remember, Jesse? EMF of a source definition. But I think as long as you give the idea that there's the change in energy going from one form of energy, so if it's a battery, then it'll be like the chemical energy to electrical energy per coulomb. I realize with the bits of paper stuck on the wall, it looks like I'm some kind of like crazy physics guy. But in fact, it's actually my wife for her degree. She's putting stuff up. She's doing a master's, so She's sticking stuff all over the place. Live with a physics teacher. Here we go. Woo, woo, woo. Hey, what do you plan on doing this video? Hey. Well, no, it's just like the AS level physics is the paper's tomorrow, so I thought people would be revising last minute. They might want to ask me anything. So VII. If you have any questions, I mean, ask me something. Maybe I'll be able to help you. I don't know. Otherwise, are you a AS level physics student, or are you doing IGCSE? How, Jack? I'm good, Jack. How are you? Now I'm using my Mac, okay, and the Mac seems to work perfectly fine, whereas my computer today. Which one of Newton's laws is my favourite? It has to be Newton's 2. The reason why, everyone always says, okay, here we go. This is a hint for the exam tomorrow. If they ask you what's Newton's second law, do not say F equals ma. It's that force is proportional to the rate of change of momentum. Okay, so that's something that seems to come up all the time. I've seen that many times where they'll say state Newton's second law, and everyone seems to write F equals ma, but don't write it. That's not what Newton's second law is. It's that the force is directly proportional to the rate of change of momentum. So please make sure you write that, not F equals ma. I know some people, for some reason, it's just they get told Newton's second law is F equals ma, but it just isn't. Yeah. Also, is viscous force the resistance in a liquid? Yeah. So viscous forces or viscous drag, whenever you have a particle or an object moving through whenever you have anything moving through a fluid, the particles have to move around, and as they move, that creates a resistance. So like viscous drag. I mean, you'll have viscous drag in air as well, but you tend to call it air resistance. But it's still the idea that you've got particles moving around the object. So yeah, it is really, if you have a liquid, and the more viscous the liquid, so for something like oil, if you had like, there's a common experiment where you fill a measuring cylinder with the oil and you get like a marble and you drop it, and then what will happen is it'll very quickly reach terminal velocity as it's going through the oil. The reason it'll reach terminal velocity so quickly is because the oil is so viscous. It'll kind of move around. It'll move around the marble or whatever's falling through the liquid. Okay, so yeah, I would say, Jesse, that's right. Yeah, so the viscous force, the resistance in a liquid. Yeah, as you're trying to move I mean, it's quite easy to move your hand through air. As soon as you move your hand through water, say if you're running a bath, there's more mass there. Okay, so that mass has to physically move around your hand somehow, and that just requires some force. Any other questions? Yeah, you're welcome. Are you writing the exam tomorrow? Oh, here's something else. Just going back to air resistance. Remember, which way does air resistance act? Okay, people always seem to think that it acts in the opposite direction of the motion. Okay, so if I've got my watch here, okay, and my watch is falling, okay, air resistance acts in the opposite direction to gravitational force. If I throw my watch up, though, as it's going up, air resistance is acting in the opposite direction to the motion. So if I have a problem, if they say air resistance isn't negligible, okay, well, when you throw something upwards, the air resistance and the gravitational force act in the opposite direction, or they act downwards. So it's something just to remember. Also with projectile motion, although you don't have to do the mechanics of projectile motion with in air resistance, it's just way beyond AS level, the AS level. But if you have something going through air, if you had projectile motion that's going through air, eventually what will happen is the force will stop the object going forwards, and eventually the only force is going to be going downwards. You better watch that because I can hear my son is on his bike going down the hill. So I think we might be really interrupted in a second, but anyway, it's fine. Anything else? Any other questions? Just write in the chat and I'll try and give you some guidance. Anything you're not sure about? Aidan, hello. Random question. Does the motion of a point on a progressive wave differ to that of a stationary wave? The motion of a point. Like a single point, I would say no, because if you've got a particle, okay, whether it's a progressive wave or a stationary wave, the particle itself is going up and down, is oscillating up and down, okay? But with a stationary wave, no energy is being transferred, okay? So with a stationary wave, you've got two waves of the same type coming towards each other, okay? And that will create the effect of superposition. So sometimes we get addition, sometimes you get where you get addition, you'll get antinodes, and where you get subtraction, you get nodes. Yeah, but I would say the actual motion of the particles is the only point I get. That actually, I suppose, in one way, actually, how they are different. Okay, is that hello. Okay.
I can see someone is broken, and then the bridge broken.
Okay, so both broken.
Yeah.
Okay.
Can fix this.
Okay, so what I would say is, okay, hang on, Carl. Let me just help these people. Okay, you're gonna sit on my knee, say hello. Okay, but they're writing their exam tomorrow, so I have to help them now. Okay. The one thing I would say, Aidan, is the amplitude, okay, of the waves. Although all particles will do a sine wave, okay. In a standing wave, closest to the nodes, the motion will be almost nothing, and then closest to the antinodes, the motion will be the maximum. Whereas with progressive waves, the amplitude is the same throughout the whole wave. So all the particles will all have the maximum displacement will be the same. That will not be the same for a standing wave. Okay, why is momentum always conserved? For example, let's take a ball hitting a wall. Kinetic energy is not conserved, but momentum is. Why is it conserved? There probably is some deep underlying symmetry in the universe that means that it has to be conserved. But that's a good point. Why should it be conserved? Why is momentum always conserved? I'm not sure. You know, it just is. I guess it's a very good point. I'll have to think about that. Okay, hi sir. Can you perhaps explain how the phase difference works in stationary standing waves? Okay. So if you have nodes, okay. Hello, baby. Let's come and say hello. Okay. So between two nodes, okay, what you would see is the antinodes all going up and down. Now between two nodes, okay, all the particles are all in phase with each other. So all the waves are going up, then they're going down, then they're going up, then they're going down. The amplitude varies. So going from the two nodes, they have almost no amplitude. Then going to the antinode, they have the maximum amplitude. But from one node to the next, all the particles are all in phase. However, going from antinode to the neighboring antinode, okay, all the particles are now in 180 degrees out of phase. Okay, I hope that. Okay, so and half a wavelength. Because in the past papers it would say the phase difference is 180 degrees, and it wouldn't say half a wavelength. Yeah, the phase. Remember, phase is given in 180 degrees. It can be given in degrees. Do you enjoy your job? Yes, I really do enjoy my job. I don't even feel like I have a job because just get to hang around with the young people and it's a lot of fun. Okay, stationary wave, the phase difference is always, that's 100%, either 180 or 0. Hi, sir. How would you calculate whether the wavelength during diffraction is n lambda or half n lambda? During diffraction is n lambda. I don't quite understand the question. How would you calculate whether the wavelength? I don't understand the question. Sorry. Think of it like when one half of the wave moves up, the other half moves down. Okay, Aiden, thank you, sir. Happy live streaming. Okay, Monique says, okay, thank you. But Chasey Centaur, hi, sir. How do you calculate whether the wavelength during diffraction is n lambda or half n lambda? I don't understand what the question is. I don't understand what you're asking me. Sorry. Does it maybe someone else understand what what's being asked? I'm not 100% sure. Happy. Huh? Cable, Carl. Just be careful with this cable. Okay, Carl. Be careful because that's on. If the cable goes, it will turn off. Carl. Okay, just be careful. That's it. Good boy. Okay. Any more questions? If you're given two wavelengths and then they ask whether a maximum or minimum is formed, how would you use those? Oh yes. Okay, I understand what you're saying now. So you're probably talking about the. Okay. What you have to do is you have to work out the path difference. Okay. So the path difference is the difference in lengths between the two sources. Screen, you're going to see either a maxima or minima. Now, if you work out what the path difference is and you're told the wavelength, divide the path difference by the wavelength. If it's a whole number of wavelengths, you will get a maxima at that point. If it's a whole number plus a half, that means one wave is going to arrive at half a wavelength before the other wave. Therefore, you're going to get cancellation, and it will be a minima at that point. I think that's your question. So where you get a well, you can go use the computer in the lounge, Carl. That makes sense. Thank you, sir. Okay, no, okay, I'm glad. We've got some little people here as well, so it's gonna make things a little bit more interesting. Okay, but okay, that makes sense. Okay, thank you. Okay, so all you need to do is just here's an example. Okay, so if you had two paths, one was 5 centimeters, the other was 7 centimeters. The difference in those two lengths would be 2 centimeters. If the wavelength was 2 centimeters, well, one wave would arrive exactly 360 degrees ahead of the other, but it doesn't matter because 360 degrees, those waves are in phase, okay, and they will add up, okay? If the path difference was, say, 6 and 7, and the wavelength, the difference would there be 1 centimeter, okay, then the wave would arrive half a wavelength, okay, and therefore they'd get cancellation. Okay, down the slope, how to calculate weight component when you have a forward force and resistance. Okay, so the component down the slope is mg sine theta, okay, and then you just subtract. So if you want the net force, it's mg sine theta minus the resistive force. That's it. So down the slope, okay, you've got the force mg sine theta down the slope, and then the resistive force going up the slope. Okay, you just, if it's an equilibrium, the two things will cancel out. Okay. Okay. Okay, Jesse, does that answer your question?
I'm going to play some.
Can I go give that mama, baby? Okay, anything else? Maybe we should get the blackboard out. It'd be quite handy. Yes, my girl. Thanks for being a great teacher. Oh, thanks, Jack. Well, I'm trying. Yes, there we go. What's wrong, my girl? If you go give it, Mum, she can open it for you. Oh, you don't want to open it? Okay.
Dad,
When the internal resistance increases, how is the PD affected? Okay, so firstly, what does internal resistance increase? How does the PD is affected? Well, you're going to have more loss if you have an internal resistance. Okay, you're going to have. Okay, so when you have an increase of internal resistance, okay, then the lost volts effect would be increased. Therefore, the terminal PD of your cell as you're drawing current would become less. The more current you draw from the cell, the quicker or the faster it will lose the or the lower it will get the terminal resistance. Sorry, the terminal PD will become lower. What does it mean? What does it mean when the galvanometer is 0? Okay, well, in that kind of scenario, you would normally have a potential divider. Carl, I'm talking to these guys. I'm trying to help them, okay?
I'm talking to these guys.
Okay. Mum, you don't mind to just come and get the guys, do you? I'm just doing a live stream. Sorry, guys, just bear with me. Okay. Okay, so what does it? Okay, sorry, start again. So, what does it mean when the galvanometer is 0? Okay, I think you're talking about when you have a potential divider. So you've got two different resistors, okay, and then a wire going across, and then suddenly you moving a galvanometer across the wire, and suddenly it goes down to 0. What that tells you is the ratio of the two resistors is equal to the ratio of the lengths of the wire. Bye, Carl. Oh, yes, the potential divider, absolutely, yes. So, when the galvanometer, okay, reads 0, okay, let me get a. Okay, thanks, Mike. Okay. When the galvanometer. Okay, we get a. Let's get a better pen. People, excuse me for 30 seconds. I'm just getting a one second. I'm just going to get a pen. I've got a little whiteboard. 1 second. I'm just going to go through the stuff now. All right, people, I am back. Okay, so so the potential divider. So you've normally got a setup a bit like this. Okay, so what's happening is you've got two resistors, okay, and then you've got a long wire, okay, and then you're going to let's call this R1 and R2, okay. Now there is a voltage, okay, across here. So this would be let's say this is a 12-volt battery, okay. So that means okay, that means this side is positive 12 volts, this is 0 volts, okay. Now along the resistance wire, Okay, if you think of a graph of the length, okay, this is what the voltage would look like. So you've got 12 volts here, okay, 0 volts here, okay, and then this is the length here, okay. So at this point here, okay, you've got this length here, L1, L2, okay. At this point here, where the galvanometer reads 0, okay, that means the ratio of R1 to R2 is equal to the ratio of L1 to L2. So you can see R1 over R2 is equal to L1 over L2. So the ratios are equal. Okay, so in that situation, when the galvanometer reads 0, okay, the length here, the length here, the ratio of R1 to R2 is equal to the ratios of L1 to L2. Why am I watching this when I'm not writing anymore? I don't know why you're watching it, but thanks for watching it anyway. So I realize there's a light bulb on behind me. So let me try and I don't know what I can do about that really. Anyway, I'll just have the light. I'll just have to stand in front here. What is terminal PD? Okay, so terminal PD, terminal, it just literally means that it's the voltage that you measure on the terminals of the battery. Now, it's equal to the EMF only when no current is flowing. As soon as current starts to flow, okay, then what happens is there's a lost volts effect. Okay, so if I draw the normal kind of drawing for what's going on with EMF, okay, so you've got little r and big R. So we've got a cell, okay, so here's a cell here. Now what we do is we imagine that our cell has a perfect battery inside, a perfect EMF, okay, but also there's little r here. Now as soon as there's any current flowing through, what happens is that there will be a voltage across here, and that voltage is what we call the lost volts effect. So as soon as the current starts to flow around here, there will be a loss of voltage across the terminals of the battery. And in fact, the graph looks something like this. So if I've got current and then terminal PD, okay, it looks like this. So when there's no current flowing, okay, so when there's no current flowing here, okay, the terminal PD is the EMF, but only at that point. Okay, so when you've got no current flowing, okay, the current is when you've got no current flowing, the voltage across the terminals is the EMF. But as you pull more and more current, you get a bigger and bigger lost volts effect to the point where there'll be a maximum amount of current that you can pull from a cell. Okay, so I know IGCSE, you just assume that all batteries are kind of perfect and you can just pull as much current as you want. But in reality, there's only so much current a battery can provide, because what's going to happen is the more and more and more current that you pull, okay, it's going to get the terminal PD will become less and less. Okay. Now, where would you see this kind of question? Okay, so in an exam, what I often describe to my students is, if you turn the lights on a car, okay, if you turn the lights on a car and you start the engine, there's suddenly a huge draw of current from the engine, from the battery. There might be around maybe 200, 300 amps of current. There's so much current being drawn from the battery, it actually causes the cell voltage to drop. It drops to maybe about 6, 7, 8 volts temporarily, then a generator will kick in, and then it will go up to about 14 volts. But where you see this is, you often see it if you're starting a car and the headlights are on. Just as you turn the key to start the engine, you'll notice the lights dim. The reason why the lights dim is because the terminal PD of the battery has become lower because there's so much current being drawn that the lost volts effect becomes very, very big, and then the cell the voltage across the batteries becomes less and less and less. Back to the question on increased internal resistance, how would that affect the current? Well, I guess the greater the internal resistance, the higher the lost volts effect would be. Therefore, it would reduce the amount of current, the maximum amount of current you could draw from a battery. Something else, going back to the EMF, if you want the maximum power out of a battery, the internal and external resistances must be equal, and that's something that sometimes comes up. How would you describe diffraction of light waves on a diffraction grating? How do I describe diffraction of light waves? Okay, so what happens is with diffraction on the diffraction grating, as the light goes into the diffraction grating, then you get diffraction, obviously, so the light spreads out. But at certain angles, the waves are all in phase. So the first beam of light to go through the diffraction grating. So if I draw again, okay, I've got my laser, okay, and then this would be my diffraction grating here. So I've got my laser here. This is my diffraction grating. What will happen is, okay, firstly, there'll be a beam going straight all the way through. Okay, so they are all in phase, and that's what we call n equals 0. Okay, because they're going all the way through. I mean, they don't care that the diffraction grating is there. Then you've got n equals 1 either side. Okay, so you've got n equals 1 either side. Okay, and then this angle here, okay, is n lambda equals d sine theta. One thing Cambridge often likes to do, okay, is just to watch out tomorrow. Sometimes they give you this angle here, yeah? If they give you that angle there, divide it by 2. It's a very common thing. I've seen them do it a number of times. Throughout my time teaching, I've seen them do it a number of times. So if you've got the beam of light coming through, okay, if they give you the angles between n equals 1 and n equals 1, and they're asking you something to do with the n lambda equals d sine theta formula, then just make sure you just divide it by 2. It's just a common little thing I've seen Cambridge do a number of times. Yenis Khan, I got an exam tomorrow to stressed out. Okay, what's stressing you out? If you feel stressed out about the paper, turn to the last page because you know it's going to be something nice about nuclear. Okay, and it's probably going to be up, up, down, and down, down, up. You know, the syllabus is changing. Oh, by the way, people, a lot of people seem to be stressing because they've been doing the specimen paper 2022. It's a different syllabus. So suddenly everyone's freaking out like, what the heck is this charm quark? But it's not on your syllabus, guys. There's a syllabus change next year. So if you've done the specimen paper and you felt like, oh, I don't understand some of this, it's because it's the wrong specification and you haven't done anything, or some of the elements are, I mean, obviously physics is physics, but some of the elements are new and you won't have seen them before. Right, people, I'm going to give it about, I think I'm going to give it about 25 more minutes. So any more questions, go ahead. Don't forget to like, comment, and subscribe, people. Oh my gosh, the YouTube classic. It's a retake. I fail for my main, but study really hard for this. Okay, well, look, you can only do your best. How did you find the practical? I thought the practical. Which practical did you do? Did you do the electrical practical? And there was a practical, and I think what was it? You had the number of resistors or something like that. I mean, it's only last week, and I can't remember it. Oh, thank you very much for the extra likes, by the way. Why did you have to retake it? What went wrong? Mikhail Kassim is randomly. Oh wow, that's thank you. By the way, NYWA. I don't know what that means. So I'm not obviously that down with the kids. But Mikhail, lovely to hear you. My gosh, I mean, I think last time I saw you, like this. Well, I can't. What year were you when I talked to you about I, you must be like a young man now. I mean, you probably even finished university. Have you finished university? But anyway, lovely to. Thanks for dropping in. Will they ever ask about Marlowe's not law? I don't even know what it is, so I guess not. I got a D. I didn't concentrate on my studies because it was online. Yeah, no, it is. Oh, you never walk. Oh my gosh, how could I forget that? You never. Can I? Okay, so I got a D. I didn't concentrate on my studies. Yeah, it's been tough. It's been tough, obviously. It was online. I hope you watched plenty of my YouTube videos. You never walk alone. Boom. Okay. Aiden, so I have liked, comment, and subscribed. In return, can I get an educational physics pun? Um, uh, uh, oh my gosh! There you see, you put me on the spot now. I'll think of one, but I might have to charge you for it. Mikhail, you'll be very pleased, by the way. Going back to Liverpool, whenever I see a Man United, one of my students supports Man United. See if they've got a pencil case, I make sure that they have to turn it face down. I'm probably going to get a load of grief off Manchester United supporters now. Thanks, Rachel. People, if I teach you, there's no way you should be doing any physics now. Okay, just relax, Rachel. I hope you have not done a single thing now since we last spoke. Do nothing. Just go for a walk or something around the block. Okay, how do we find the electric force acting on the nucleus? Okay, so E equals F over Q. Okay. You've got a lot of jokes. Okay, so this is the electric field strength. So E is electrical field strength. F is the force on the nucleus, and Q is the charge. So remember, the charge will only come from the protons. So if they give you the number of protons and neutrons, they could do. You only need the number of protons, times that by the electric strength of the electron, so the magnitude of the electric strength. Okay, so you do the number of protons times by 1.6 times 10 to the minus 19, times by whatever the electric field is. So it'll either be newtons per coulomb or volts per meter. Okay, but that's how you'd find the force acting on the nucleus. That's assuming it's a complete nucleus. There are no electrons orbiting. But I don't think Cambridge would do something that kind of chemistry in a physics kind of paper. So I don't think you need to worry too much about that. Anything else, people? I'm sorry if the light behind you is bugging me, but bugging you. But okay, lovely. Thank you so much. Pleasure. Okay, someone else has seen that question before. Was there was like a grain of dust, okay, and then there's a positive and negatively charged particle, and they were in an electrical field, okay. So it was something like that, okay. So you had like a grain of dust or something like that in an electric field. So the negative charge would experience a force to the left. The positive charge will experience a force to the right. Okay, but then they wanted to know what was the turning effect of the couple. You just had to work out the force of one. Okay, so F S. Okay, but then you had to work out the direct distance. Okay, sorry, the perpendicular distance between the line of actions of the forces. Okay, so you'd say Fs, but it was this angle here, and I think, sorry, this length here. They gave you the distance from here to here. So they gave you the distance from here to here, and then I think they gave you this angle here. So I think you had to use either, I think it was cos that you had to use to work out this distance here, and then you'd use the force of one of them times by this distance, and that would tell you the moment about of the grain of dust. That's just something like that. Anything else, people? You got about 20 more minutes. Then I'm going to bed. I wonder where. Okay, here's a bit of a question. Where is everyone in the comments? Where is everyone? Like, are you in South Africa? Are you somewhere else around the world? And I know there's a lot of my students watching, so most people will probably be South Africa. Not as truth is, if I was you guys and I was writing an exam tomorrow, I don't think I would do any physics right now. You've probably done a year and a half of physics. Just listen to me chatting on about it. It's probably be fine. You've probably easily done enough physics over the course of a year or year and a half. You'll be absolutely fine. Yeah, so don't. The honest truth is, I know that everyone does their revision last minute because I see it every single year. Okay. What happens is I always know this because my views on my YouTube channel just do this. Bloop. Okay. Where are you from? It's actually my first time watching it. I'm actually originally from the UK. I'm actually Jenna, sir. Okay. That's funny. Okay. Hi, Jenna. Where are you from? It's actually my first time watching. Okay. Originally I'm from the UK, but I'm currently in South Africa in Cape Town. Okay. Hi, Jenna. I'll have to ask you about this name. But please stop doing any physics. Don't do any physics. You've done enough. Okay. If you got any, like I say, any last minute questions, go ahead. I'm a chemistry multiple, and I'm stressed. Please suggest how I could revise all the chapters. Now you want to revise all the chapters now? Okay. I have my chemistry multiple choice tomorrow. I'm stressed. Please suggest how I should revise all the chapters. That's hard. I can't. I mean, firstly, I'm not a chemistry teacher, so I can't really help you with chemistry. There's always also that really annoying thing with chemistry. What is it? They only give you like 3 answers, and then is it A and B? Is it B and C? Is it D alone? I did remember like a chemistry teacher telling me there's a logical way of thinking about it, but to me it seems a bit confusing. So I'm very sorry. I have taught a little bit of chemistry, but how I should revise all the chapters in one go, I'm afraid I'm just not qualified to help you. So I just can't help you. Sorry. Harry Potter reference. Anything else from anyone anywhere? AMA, ask me anything. So what Payush Shika? What are you can't be writing chemistry? Are you writing the chemistry AS level for Cambridge? Because I don't think they'd write the physics and the chemistry would be done at the same time. I'm pretty sure they wouldn't be done at the same time. So, are you doing O level or IGCSE? I'm just wondering what you're doing. Jenna, I think you must be addicted to Harry Potter. It's what's crazy is like the Lego is so popular now. You know, how can it's funny that the Lego is the Lego Harry Potter. Like, when was the last movie? Okay, IGCSE. Okay, look, just go through past papers. But the exam is tomorrow, so I would have suggested you probably have been through past papers already. And if you've been through past papers, and I would suggest that you just have a night off. Don't do nothing, because if you've done your due diligence and you've gone through as much as you can, and there's really very little point in doing anything tonight. Just have a bit of a chat. It was a big thing for me when I was younger. I've got to say, I'm sorry to say, I've only ever watched the first Harry Potter movie. My sister was big into it, but I don't know. I think I always like sci-fi. Like fantasy was not my thing. Jenna, I'm sure I'm going to get a crossed look tomorrow. So don't kill me. Okay, back to the dust question. How would you find the talk of the couple? Okay, so the force on each particle. Okay, so how do you find the force? They give you the charge. They tell you the strength of the electric field. Okay, so E equals F over Q. So F is, let me just write it down here. Bear with me. So E equals F over Q. So the electric field strength times by E is going to be the force. Okay. But it's doing something like this. Okay. I'll call that S. So, okay, so the force of one pot is going one way, the force is going the other. Now, in the question, the forces are identical. Okay, so the forces have to be identical for it to be a couple. So then all you do is you have to work out what's the distance between the two of the forces. So what's the distance here that is perpendicular between both the lines of action of the two forces? Now, I think in the question they give you the length of the grain and they give you the angle. So I think it was actually had to use sine, but I can't remember off the top of my head what it was exactly. But it's something like that. So you have to work out, the force of one of them. You work out the distance between the two lines of action of the forces, and then just multiply that distance by one of the forces, and that's how you're going to find the torque of the couple. Jenna, I'm going to say this on my YouTube channel, then it's just going to be here forever, chatting away about Legos. The Lego is a lot better. Yeah, it's weird. Like, it's weird how the Harry Potter Lego has suddenly become better than it ever was during when Harry Potter was out in the cinema. It's just it's such a weird kind of thing to kind of revive. And also like Jurassic Park as well. Like, something seems to be like, Jurassic Park Lego. And I guess Star Wars, but I don't think Star Wars is ever going to end, is it? I'm not complaining, sir. I know Pino's got the Harry's book. I guess the fan, yes. Oh, I see. So what's happened is the fans have literally grown up, infiltrated into the Lego organization, and then have been like, let's make more Harry Potter stuff to get the new generation of Harry Potter. Yeah, Star Wars is eternal. All right, back to physics. Any last minute questions? You got 10 minutes. 10 minutes. Otherwise, after this, I would suggest just do nothing. Go sleep. Also, I'm very sorry to the people who've got a class tomorrow and they have to write English before they have to write physics. I thought that's really not fair. Are there any good written notes I can refer for physics? Yes, there's my notes. But they're all. Here's a problem. They're all at school, so what I always suggest is Payush. Let me try and say your name right. Payushika. Payushika. I hope I'm saying your name right. If you want to go, if you're doing IGCSE physics, I would suggest go through my YouTube. There is a change to the syllabus for next year, but hopefully you'll if you look through my videos, hopefully they'll be able to help you. But for written notes, I tell you what is also good. Z Notes. I don't know if Z Notes is still available. Let's have a look. Or Z Notes or Z Notes. Can you like sign up? And that's never fun. Signing up for stuff. Free access. So you're doing. They call it CAIE, not CIE. CAIE or physics. 09702. But is IGCSE. Yeah, physics 06. Okay, here we go. Maybe check out the Z Notes. I always thought they were good. Yeah, I know a lot of students have liked Z Notes. Anyone else got any good source of notes for Yoshika? Oh no, you're very welcome. Anything else? 7 minutes to go. For the record, the notes on the wall are not mine; they are my wife's. Well, Jen, I hope so, and I think I'm going to come see you guys. What time do you guys write physics? Do you know? Okay, could you explain weak interaction, nuclear physics? Okay, so the weak interaction is what causes beta decay. Okay, I'll see you tomorrow, Jenna. Okay, 8 o'clock in the morning. Oh, that's not Jane, right? Okay. Okay, I'll come to you guys before you write. Okay, could you please explain the weak interaction? Okay. What's the weak interaction? So weak interaction is responsible for beta decay. Now, annoyingly, in the current syllabus, it does not explain something called the W boson. Okay, so you have to basically say, okay, if what's responsible for beta decay, the weak interaction or the weak nuclear force is responsible. However, there is not, that's the end of the statement in the syllabus. So you don't need to understand there is really a force carrier called the W boson that is responsible for changing the quarks either from up to down or down to up, and then that W boson then changes into either an electron and an anti-electron neutrino, or positron and an electron neutrino. But it doesn't say that in the syllabus. So your teacher will have hopefully just said, well, what's the cause of beta positive and beta negative decay? It's the weak interaction. That's it. That's all you have to say. And that's as far as the syllabus goes. So I think I'll just stop there. Okay. About the ATP for physics. Okay, the alternative to practical. Okay, it's just basically it's an exam. It's a very unusual exam for physics in the IGCSE, in that I think it's worth about 20% of the IGCSE. In fact, I'm pretty sure it is worth about 20%. There's a lot of reading in it, unusually for a physics exam, and also there's no real calculations. There's some, they do assume some knowledge of the course, but not really. It's more about either there's always one question where you have to invent your own exam, okay, or your own exam, your own experiment, okay, or it's a case of looking at thermometers or stopwatches or something like that, and then interpreting the information that you're being given, and then like graphing the data, working out gradients, things like that. So the ATP for a paper is oddly quite skills based. Well, it is really skills based. So I think maybe that's all I can really tell you about the ATP. So I want to know about quarks. Okay, so in terms of the current syllabus, so 9702, you're only meant to know about 3 quarks, although in reality there are in fact 6 quarks. So for the 9702 syllabus, there's the up, down, and strange. And strange is almost identical to the up quark in that it has the same charge, it has more mass, and of course it has strangeness, annoyingly strangeness of -1 rather than a strangeness of 1. Why? Because nuclear physicists are kooky like that, and just think this kind of thing is hilarious, that we will just make strangeness negative than what it really should be. So basically, you can build up hadrons. So hadrons are a form. Sorry, you can build up hadrons. Okay, you can build up. So you've got particles, all particles, and then you can split that into 2, into leptons and hadrons. Hadrons are made of quarks and antiquarks. And then the family of hadrons can be split further into 2, into mesons, which are quark-antiquark pairs, and then baryons, such as baryonic matter, okay, such as protons and neutrons. Now, they all contain 3 quarks, and depending on what the flavor of the quark is, will tell you about the charge. So, for example, you're expected to know that a proton has 2 ups and a down, and that's what causes it to be positively charged. I think I just messed up the charge. I think it has the strange quark is the same as the down. I think maybe someone will put this in the comments. What is this? Maybe it has got this. Yeah, because it can't be the same as the up. The up is +2. So the up quark is +2/3. Okay, so the down is -1/3. So for the proton, you've got 2 ups and 1 down. So that's +2/3, +2/3, -1/3, which gives you a positive charge of 1. Whereas with the neutron is neutrally charged. It has 1 up quark and 2 down quarks. Why does that mathematically work out? So you've got +2/3, -1/3, -1/3, and that gives you a charge of 0. Yeah, D is -1/3. Yeah, oh yeah, so I think the strange quark has the same charge as a down quark. And then it will change. The strange quark is very, very unstable, so it will change into a down quark. I think that's what will happen. Can I ask us questions on fundamental modes? I haven't seen a question of those before. No, I don't think so. You mean for standing waves? No, I don't think so. This was great. Thank you so much. Okay, well, I'm really glad. Okay, I think I'm going to call it a day then. I'm glad hopefully this has been useful. I would suggest you do nothing. You probably, if you're a conscientious student, the kind of person that would watch a YouTube channel just to see if there's any last little bits and bobs to go through, I would suggest you do nothing. Just go to bed, or if it's a different time zone, you still got a little bit of light, then just go and get a little bit of exercise, and good luck for tomorrow, guys. I'm sure you're going to be fine. Okay? And if you don't forget to give us a little like. All right, okay, guys. Okay, I hope you do well, and all the best. Bye for now.